Okay, so in this morning's work we're going to extend further the angle property knowledge that we revised yesterday when we were looking at triangles and quadrilaterals and straight lines. That work was predominantly ED. When we move into parallel lines it's more challenging, and then we're into the sort of grade C level of questions, so they're further into the intermediate tier paper. And of course, if you can get these right, then that's really boosting your chances of a level 2 grade out of it. So just to summarise, lines are said to be parallel when they're always exactly the same distance apart. So if you imagine crudely 2 pens there, if they're like that, they're not the same distance apart, because down here they're about, sorry you can't see that, they're about 8 centimeters apart, but here they're only say 3 centimeters apart, so they're not parallel. For them to be parallel, it would mean that wherever I placed my ruler, they'd be the same distance apart, and if they're the same distance apart, they'll never cross. Yesterday we looked at the notation for the parallel line, and it's arrows. And what I'm saying here is the classic example we use as teachers when we talk about parallel lines is train tracks. Train tracks have to be parallel, otherwise the trains drop off them. But another example that I could use, and we'll be using when we come to look at bearings in a few weeks, is the north-south line on a compass. It doesn't matter where you are on the planet, your north-south is always going to be the same. It always points to north. So wherever you decide to put your compass on the planet, it will always produce parallel lines with any other north-south line. So that's one to bear in mind for a few weeks' time. So when parallel lines are crossed by another line, a traversal, okay, then a series of equal angles are created, and the traversal on the diagrams here are the ones that are crossing the parallel line. So you can see I've got a pair of parallel lines and one that cuts it, and it's that cut that creates the series of equal angles. When we work with pairs, more often than not, we work with pairs of parallel lines, but they can be any number, and when we look at the exam questions in a moment, you'll see that quite often you have more than one pair, or more than 2 parallel lines. And the equal angles apply to all of them. So here are the 3 properties that you need to remember. First one are alternate angles, and alternate angles, think Z. Okay, so if you imagine you've got this sort of stretched Z acting there, then the angles inside that one and outside that one are equal, and similarly with that reflected Z, the yellow ones are the same. And generally you can't measure these. Each question will say they aren't drawn to scale, but just by looking at them you should be able to see, well, that one's acute, that one's acute, so they must be the same. It's not ever going to be, well, that one and that one must be the same, because clearly they're not. One's obtuse, one's acute. So those are the alternate angles. Then we've got the ones which we call F angles, which, if you think that we've got that letter F there, or its reflection, then the angle inside the sort of F there and there are the same. So those 2 are the same, and similarly opposite, those 2 are the same. But once you've worked out one, you can work out the other, because you can then apply the straight line relationship. And then the final one, which isn't equality, it's, if you think of a C angle, so if you think we've got a sort of letter C there, then the angles inside that letter C add up to 180. So that one plus that one equals 180. So those are the 3 relationships you need to remember. You're not given them, you have to spot them. So exam questions are often structured to include not only the parallel line properties, but the ones that we looked at yesterday on straight lines, intersecting lines, triangles and quadrilaterals as well. So we'll have a go at some together, and then on the Google Slides you can have a go at some of your own. Right, so I need to find the size of each angle A, B and C. And we've got one pair of parallel lines, so it's the two sloping that way are parallel, but I've got two traversals. I got this one here, and I've got that one there, and they need to be treated separately. Now, as I said yesterday, generally, when they've labelled them A, B and C, the order that you find them, A, B, then C, tends to be the easiest way. Not always. Sometimes they're standalone, but in general that would be the best way of working with them. So what we have here is I've got that one's 123. If that one's 123, if you look down here, what we've got is that sort of F, but it's an upside down F. So that angle there must equal that angle there, and it looks the same. They're both obtuse. So A is 123. It's the same as that one there. So A is 123. And usually what I would suggest you do is scribble all over your diagrams, because you can see there what you know. So I know that one's 123. Now 123 and B live on a straight line. So B is going to be 180 take away 123. So that's 57 degrees. Okay, so I know those. Now C is on this different traversal, and I'm looking straight away for my favourite parallel line one, which is the Z angle. If C is 74, sorry, if that one's 74, so is C. So A is a parallel line property, B is a straight line property, C is a parallel line property. Number next. So we've got loads here. I've got one pair of parallel lines, AB and PQ, and then I've got these two traversals that cross on the top parallel line. So line AB is parallel to PQ. Find the size of each of the angles A, B and C. Okay, so A should be the easiest spot, and I can see straight away I've got that Z, so A is 52. Let's write that in. B should be the next easiest to spot, and I can see here that I've got these intersecting lines and I've got the opposite angles there. So if A is 52, B is 52 as well. Okay, what else do I know there? So to work out C, I can't work that out yet, but I can see that C is a Z with X. So if I can work out X, C will come from it. And I can see that X lies on a straight line with 116. So X is actually the next one I can find, and that's going to be 180 take away the 116. So that's 64 degrees. So I know that that is 64, and now I've got the Z going up to C, so C is 64 as well. And that allows me then to work out what Y is, because now I've got this straight line here, so I know that the 52 and Y and 64 have to add up to 180. So y would be 180 take away 64 take away 52. So 180 take away 64 take away 52 equals 64. So that one there is 64 as well. So I've done part A. Find the size of each of the angles x and y. Oh, I've done that. So I've done B as well. Hence, give the special name for triangle LMN. So triangle LMN is this triangle LMN. And they want the special name for that triangle, and I can see that I've got one angle is 52 degrees and these two here are both equal, so it's an isosceles triangle. And that's a classic example where it's not the bottom two that are the same, it's in this case it's x and y that are the same, which means that that side and that side are the equal lengths. And then two more. So ABCD is a rectangle. ABCD is a rectangle. AB is parallel to EF. AB is parallel to EF. Okay, so those are my parallel lines. And AC, CE, and DG are straight lines. AC, CE, and DG are straight lines. Find each of the angles A, B, and C. Okay, so A, I can see is inside this triangle, and because it's a rectangle, that means the diagonals are the same length, so that means that that's isosceles. So for angle A, it's going to be 180, take away the 110, which is 70, divided by 2, which is 35. So that angle there is 35 degrees. So I've written 35 in there, although it's not clearly, can't clearly see it. Now, I know that that's a straight line, and I know that that must be a right angle because it's a rectangle, which means that must be a right angle as well. So to work out B now, I'm looking at this straight line that my pen is running along. That has to add up to 180. I know angle A is 35. I know that's 90. So to work out B, I've got to do straight line, 180, take away the 35, take away the 90. So angle B is 55 degrees. So I now know that that is 55. I know that this is a right angle. It's a right angle triangle. It's a Z with that because they're parallel. So that means I can work out what that is by doing 180, take away 90, take away 55. Which is 35. So I know that that angle there is 35, and then I'm on another straight line, so that the 35 plus C must add up to 180. So C will be 180, take away 35, which is 145 degrees. So C is 145. And then the final one is an example where we've got three lines which are parallel to each other. Find the size of each of the angles A, B, and C. Sorry, no, that's the top one, isn't it? Calculate the size of angle X. So I need to work out what that side, that angle there is. Now then, I have got a triangle there. So if I can work out the angles inside that triangle, that will allow me to work out angle X. So if that's 113, that's on a straight line, so that angle there is going to be 180 less 113. (67 degrees). So I know that angle. Here I'm in my Z. So if that's 38, that's 38. So that now means that inside that triangle, I got one angle I don't know. So the question mark there will be 180 less 67 less 38. (75 degrees). So that side is 75 degrees, and then on a straight line here, so 180 less the 75 will give me X. So X is going to be 105 degrees. So these sort of questions never used to stress me out when I was doing maths as a pupil. I used to just treat them as a puzzle. And if you do that, then you won't get too stressed about it, and you should be able to figure these things out. Have a go now at the questions on the Google Slides, see how you get on. If you can't do one, just move on to another and then go back to it, and maybe a penny will drop with some of the questions that come afterwards.